we're asked to solve triangle ABC. Whenever we're asked to solve a triangle, we could either use law of sines or law of cosines. Unless we know it's a right triangle, then we can use right triangle trigonometry. But we don't know that here, so we'll need to choose either the law of sines or the law of cosines. If in our given information we have a matching angle and side, that is a clue that we will begin the problem with using the law of sines. So the law of sines says that when you take the ratio of a side with the sine of the angle across from that side, that ratio is consistent throughout the triangle. We can put the side divided by the sine of the angle on and the sine on the bottom, or we can put the sine of the angle on the top and the side on the bottom. It doesn't matter as long as we're consistent when we set this up. In addition to the law of sines, when you go to set it up, you want to be on the lookout for, do I have two sides and a matching angle? Because what that means, if you do, is you have what we call the ambiguous case. And that's what we're dealing with here, the ambiguous case. We have two sides, side A and side B, and an angle that matches up with one of the sides. So we've got some options here. Either there's no triangle, there could be one triangle, or there could be two triangles. And the way we will decide is we'll set up a little inequality. That inequality will be the side across from its matching angle compared with the other side times the sine of that angle. If this inequality comes out less than, that means no triangle exists. If it comes out equal to, it means there is one triangle and it's a right triangle. If this inequality comes out greater than, then we've got a couple of different options. We would next compare 2 and 7. If it comes out less than, then there is going to be two triangles. If it comes out greater than or equal to in that second layer comparison, there's going to be one. So let's see. We'll take our calculator and we'll plug this in, and we end up finding out that 2 is greater than 7 times the sine of 13 degrees. All right, so now I know there's at least one triangle, possibly two. So I will compare 2 with 7. The result is less than. That tells me large enough to make a triangle, short enough to swing and go twice. There are two triangles here. And when we're solving, if there are two, we need to make sure that we find both. All right, so we'll start with triangle 1. We know that angle B and side B will go together, so I'll put the sine of 13 degrees is to 2 as the only other piece of information I have is 7, so it's a side length. It's going to go on the bottom. It's side A, which means we would have to have the sine of angle A on top. We'll cross multiply. 7 times the sine of 13 degrees is equal to 2 times the sine of A. When we divide by 2 on both sides, we get that the sine of A is equal to 7 times the sine of 13 degrees divided by 2. And that's the sine of the angle. We want the actual angle itself. So you would do inverse sine, or arc sine if you prefer, of this information. Again, our calculator is invaluable to us as far as doing these calculations. And we find out that A is equal to 51.9 degrees. At least that's the first possibility. So we'll go ahead and finish out finding the information for the first triangle. So A sub 1, the first option for A, is 51.9 degrees. Well, we knew B was 13 degrees, so C sub 1 should be equal to 180 minus 13 minus 51.9, which is going to be equal to 115.1 degrees. Okay. Then the only piece of information we're missing now is side C. So I'll set up another law of sines. Sine of 13 is to 2, as the sine of 115.1 degrees is to side C sub 1. Cross multiply and divide, we end up with C sub 1 is equal to 8.1 rounded to the nearest tenth. Okay, so case 1 has all of these features. All right, now for case 2. The other possibility for A, we'll call that A sub 2, would be equal to 180 minus 51.9 degrees. Well, 180 minus 51.9 degrees is 128.1 degree. Okay, so that's A sub 2. We need to find the other possibility for C sub 2. So that's going to be C sub 2 would be equal to 180 minus angle B, that's common to both triangles, 13 degrees, minus 128.1 degree, and C sub 2 is 38.9 degrees. And last thing we need to find, the other possibility for side C. So we set up our law of sines. The sine of 13 degrees is to 2, as sine of 38.9 degrees is to side C2. When we cross multiply and divide, we find that side C2 is equal to 5.6. So the other possibility for what this triangle would be is angle A being 128.1 degrees, angle C being 38.9 degrees, and side C being 5.6.